everybody. I hope you all are very excited to learn a little bit about AI, and specifically, we are going to talk a lot about generative AI. So, and also what we are going to cover here is like how the integration, the role of integration in building AI applications nowadays, because we have this generative AI. So this is something very important to talk about. And also we will discuss like what are the common integration patterns that we have when we are talking about generative AI. And also another thing, we will extend our talk to discuss the need of retrieval-augmented generation. I will discuss all these things in detail. Right now I'm just going through what we are going to do. And also about the agents. I think it's a very hot topic nowadays. You guys have heard about it. And also we will talk like why we need Model Context Protocol, MCP. And also, we are eager to build very good AI applications, right? But when we are building these AI applications, we have to be responsible as well. So the AI has to be responsible. They have to have certain guardrails, they have to have certain governance. So we'll talk about those concepts as well. And also we'll talk about a zero trust design for AI agents, because you may have heard about the zero trust architectures, zero trust designs, but that's not for AI, right? That's for other stuff. But we will now bring that concept into AI as well, specifically to the AI agents. I think I have to move out of the screen because everything is shown there. Yeah. So before moving forward, I would like to define these terminologies, because in case if you're not sure, so what is AI? AI is anything that can simulate human intelligence. It can be a small function as well. It can be a machine learning model. It can be a very big deep learning model. Right? It's anything that actually simulates human intelligence. And what is actually the generative AI? So generative AI is, again, a subset of artificial intelligence, where we are actually focusing on creating original content that can be text, that can be audio, that can be visual stuff. It's basically focusing on creating or generating more content. And what is large language models or LLMs? So this is example of like ChatGPT, OpenAI, all the stuff, right? Those are large language models. What is that? And that is actually again a subset of generative AI, but focus on natural language. So understanding text, generating text, and that's what its specialization. Okay. Now, another thing I want to discuss a little bit is why now? Why we are talking about AI now? AI was there for a long time. People are trying to build a lot of stuff with AI. But now things have changed, right? Something has changed. So I think the key thing is, unlike before, unlike the pre-GenAI era, now AI is for everybody. It's not just for the AI developer or that machine learning expert who could build machine learning models. It's for everybody. For example, in the previous era, when we build machine learning models, when we build deep learning models, we were working with a lot of numerical or categorical features. And we have to feed those features into the model. We have to process them. We have to clean them. There are a lot of things involved with that. But now it's just chatting with the model, right? You just say to the model what you need, and the model will do it for you. So it's just a conversational experience for you now, if you want to use AI. And the other thing is, now, in previous era, when we want to build any AI experience or any AI application, we have to train a specific model. And we have to go through all these steps like train, tune, deploy, fine-tune, all those stuff. And also, the training will happen, the learning process will happen when you are training the model. So that was the previous era. But now it has changed. Now we have these large language models, which will work for different domains, different tasks. You don't have to fine-tune it. You just have to tell it, OK, do the text summarization or do the sentiment analysis. And it doesn't have to be in the same domain. So you can apply it for different domains. And also, they are available as APIs as well. So the accessibility is very easy now. You don't have to train it. You can just do an API call and basically access them. And the other most important point is, They can also learn, but I mean, of course, we can train them. Somebody has to train them, right? Somebody has already pre-trained them. And we can also fine-tune them. But another important thing is, they can learn during the inference as well. Of course, it's temporarily, but you can feed more information to the prompt and teach these models more information, and then get them to do your task. That's a very important capability, which wasn't available with previous era of models. Yes, so you're like saying generative AI is great, but now let's discuss like what is actually the limitations, or what are the problems with generative AI. I think one of the main problems, I think, is the key challenge with generative AI is the hallucination. Hallucination means these generative AI models, they can lie to your face, and you will believe it if you don't know your facts. So it can convince you really well. If you don't know the facts, you will believe it. So that's how good they are at lying, and that's a big problem. I mean, if you look at the examples, these are like examples taken from like early generation of generative AI models. They may not work with current state-of-the-art generative AI models, but you can, it is just to demonstrate. Like, for example, if we take the first scenario, we ask like, who was the first person to walk on the moon? And it's just making up facts and saying a different person. We all know who was the person who walked on the moon for the first time, right? And just making facts, right? And then telling, okay, this was the guy, and that was during the Lunar Pioneer mission. And this is a type of hallucination where AI actually, the model actually doesn't know the fact, so it's just making it up. And that's okay for these models, because these models are not actually any fact generation models. They are content generation models. They are supposed to generate some content, right? They are not supposed to, we don't train them to generate the factual, correct content. That's how they are. And the other case is now, to overcome these kind of problems, we can actually give some context to the model, give some context to the prompt, and say, okay, this is the information. Like, for example, in this scenario, we are telling in early October 23rd, the war broke between Israel and Hamas. And then we ask the model to summarize that. And in the summarization, the model is saying it's October 2006. And even we give the information to the model, still it can hallucinate. So that's, again, a problem, right? And another problem they have is they are not, that good with mathematical problems. We assume they are good, but they are not. But again, these things have been fixed and improved a lot with fine-tuning for the current state-of-the-art models. And this, again, major limitation we had back then. And also, this is not something we are, as integration developers, we are not that interested in this problem, because we are not going to solve mathematical problems using generative AI models. So I'm just going to skip it. But keep in mind, that's another limitation they have. Now, we are talking about the limitations of these models. Of course, we have to talk about some solutions also, right? How we can overcome them. So one way to overcome it, that is to use proper prompt engineering. That means like you instruct the model in different ways, so they don't run into these pitfalls. And another way to solve this problem is, it's actually part of the prompt engineering, that you integrate the generative AI models with your systems or your data. So that model has the context that it doesn't know. Of course, you will end up with having a combination. You will need the prompt engineering plus integration with data when you actually want to build real-world applications. Let's talk a little bit about prompt engineering, because we can't just skip that and go directly to the integration. So if you look at the prompt engineering, there are like a lot of techniques now. For example, we have zero shot, few shot, chain of thoughts, and then we have the direct stimulus, prompt chaining. There are a bunch of prompt techniques. I'm not going to take you through one by one, but if you look at them, we have a bunch of techniques that actually use single LLM invocation to correct the issue. That's the zero shot and few shot, those stuff. And then we have this multiple prompt techniques. That means like it will use multiple iterations of LLM calls to actually correct this issue or overcome the limitation. And then we have this interesting type where we actually use prompt techniques to connect LLMs with external tools, so external world. That's the RAG, React, Reflection, those kind of techniques, which are actually very useful because then you can do, a lot more with these models. And we will discuss about this stuff in coming slides. So to take a simple example, how the prompt engineering works, so I think it's very interesting to look at it. If you look at the few-shot prompting, this is one of the basic prompt engineering techniques. So in the left-hand side, we have the zero-shot prompting approach, where we just instruct the model and say, classify the text into neutral, negative, positive, and then we give the text, I think the vacation is okay. And then we ask the model to give the sentiment, and it say it's neutral. That's basically directly telling the model what to do. But in the few-shot prompting, we have given some examples saying, okay, this is awesome and it's a negative thing, and this bad and it's a positive thing. And what's the movie was? Yeah, I can't see that close, but you can see like what we have some of this stuff, right? And we have given a set of examples to the model or the LLM, and then we have expected the model when we give the new sample, like what's the horrible show, and it will basically give us the correct answer. That's what we have expected. So we have expected model, by looking at the examples, you will give the correct response. And we haven't instructed it at all. We haven't tell it you are doing a sentiment analysis. We haven't tell anything. And this is a very important pattern because let's say now you have thousands of instructions that you have, or hundreds of instructions that you need to give to the model to follow whatever the task you want to do. You can avoid all those things just by giving a set of examples. That's why this is very important and powerful prompt engineering technique. And of course, so I will show you like what kind of a prompt we are using usually when we are building these kind of applications. So this is the structure of the prompt. So we have the role first. That means like we are telling, okay, you are a Barana developer, you are a Java developer, and then it will, and the LLM will impersonate that personality. And then we give the instructions, okay, you are supposed to generate the code accurately, and these are the instructions, you have to follow this stuff, right? And then we also give an output format and say, okay, you have to respond in this format. And then we have the most important part, where we give the context. That's where we add the missing pieces to the LLM. And then we can say, okay, these are the existing libraries that we have, because the LLM doesn't know, like even if it knows, that knowledge can be outdated because we are doing a lot of releases, right, every day. And then we can give a bunch of examples following the few-shot prompting, so we can reduce the amount of instructions we can give, and then we can give the actual question coming from the user. So this is kind of the structure that we are using when we are building generative AI applications. Yeah, now we are at the interesting part where we are going to discuss about GenAI integration patterns. So when we are talking about GenAI integration patterns, one thing that happened in the most early era of generative AI was just integrating these generative AI models in your application. Just having it there and just prompt it, and you have this ChatGPT-like assistance. You can just have a conversation with your integration and basically get some output. And it will use the model's knowledge, so it's not going to look into any external stuff. Very simple case is like code generation. Like you can do code generation without any external stuff. So the model is capable of that. If you want to generate in Python code, you can just ask ChatGPT also, right? It doesn't need any tools or any external knowledge. And then we have the other case where actually we get some other APIs, databases, real-world data, a context, and you integrate that with your application, so you can feed that into your prompts. And this is really powerful because now you can solve the knowledge cutoff issues with the model, because the model knows only limited stuff, right? And also maybe it's outdated, so you can solve all those problems. And also for the enterprises or the businesses, there is a really good advantage, because now you can add your private data to the model, which OpenAI doesn't know, which Anthropic doesn't know, because they don't know what is happening inside your business, right? So all those stuff, you can now add it to the prompt and basically integrate with those data and use this pattern. For example, if you have already downloaded WSO2 application, you will see we have a feature that suggests that suggests sessions using AI based on your preferences. And of course, we have a background agent running who knows like very simple stuff about it, like your name and your destination, like the job title and the company, only basic stuff. And that background agent can do a web scrape and basically find out whatever the public profile you have, and then extract only your technical interest. Okay, we are not extracting any other interest, only the technical interest. And we have that in a database. And also we have our updated agenda or the session timetable in an API. So we have all those stuff. So now what we can do is like we use this GenAI integration pattern to basically connect to the WSO2 API and also the user profiles that we have created, and then give you these nice suggestions. I mean, when you open it, you will see it will say, okay, if you are interested in AI, go to this AI lab. And this is the architecture of that. So if you look at it, you have the user. So user basically, I mean, he's checking the sessions, right, from the mobile application. Then it will send a request to our session integration, and that will have the user ID, only the user ID. And then we can basically get the agenda information and also use the user ID to get the profile of you, and then use that in the prompt to the LLM, and then we can get the suggestions for you. Okay, so what are the key takeaways so far? So we discussed like writing better prompts matters, and actually that's the new programming language that you build AI applications. And then the second thing, the real power is behind how you integrate your data into your generative applications. So it's not about training anymore, it's about integration. Okay, now you're talking about like basically stuffing our data into the prompts, right? Now everybody has the question like, I mean, I believe you have the question, can we like add all my organization's data into the prompt and basically ask any question I want? I mean, will that work? Of course, no. There are certain limitations. Like there is a technical limitation. These models, they have a context size that they can handle. For example, I mean, there are some models. I mean, the early era models, they handle like 4,000 tokens. And when I say token is not actually a word, but you can imagine it as a word. It's okay, but it's not actually a word. It doesn't map one-to-one, but it's similar to that. So in early era GenAI models, they support like 4,000, 2,000 tokens for each request. And now we have models that support a few 100,000. Even I think there are models that can support 1 million token context window. But the thing is, like, even if whatever the model you are using can support like 1 million, 2 million, there's another problem. Like, you don't want to fully utilize that. That's because it will basically increase your cost, because you have to pay for each token that you are consuming. So when you put more information to the prompt, that means you are paying more to OpenAI, so OpenAI will get rich, you will get poor. And the other thing is, it will actually reduce the accuracy of your task as well, because now you have a lot of information in the prompt. That means the model has to do a lot of work to figure out what are the information that is actually required to do your task, right? That's again another limitation. And of course, you will have higher latencies. That means like slow response times. And that's because, again, you are doing a lot of processing when you have a lot of data in the model. So I'm trying to not move there. Maybe it seems like I'm dancing here. But I really like to move around the stage, but I can't because it cover the presentation. So yeah. So you're talking about like why we shouldn't do that, and now we have the solution. The solution is Retrieval-Augmented Generation, and that we may have heard about that. That's the RAG that everybody is talking about. It's not that we are ragging the LLM model. It's just a way that we efficiently use our data on our LLM models. And the idea is very simple. Don't put everything to the model prompt. Just put what is relevant and what you seems as relevant. Of course, it's very simple, but how to do that? That's the main problem, right? So what RAG suggests is, before just putting your data into the prompts, first you take your data and index your data. For that, you can use these vector embeddings and vector DB. I will discuss that concepts. So now just think of as we are creating a certain index, a search index. And when you have that search index, when you get a question or a task at the runtime, what you can do is you can look up that index and then figure out what are the things that are more relevant, right? For example, when you want to find out something, you just Google it, right? So Google will use a search index and get you the links that are relevant to your search query, similar to that. And then you can feed only that information to LLM and get your answers. So that's what this diagram also explains. So you get the query, and there's an index. An index will basically figure out from the index data what is relevant, and then it will be fed to the LLM model. Sorry. Okay. Now, to understand this a little bit in deep, let's try to understand what is a vector embedding. So vector embedding is it's a very simple thing. It's just a numerical representation in a high-dimensional space. And for your words, for your paragraphs, for your sentences. In this case, to make it very simple, I have used words. But when you build RAGs, we are not actually doing the vector embeddings for the words. We are doing it for, maybe paragraphs or maybe certain pieces of text documents. You don't have to do it for each word, okay? So here, if you look at this, now, I was telling like it's a high-dimensional representation of a given word or a text. But I think it's better to illustrate with the diagram what it means. So if you look at this, now we can see like each term or the word has been represented using a three-dimensional vector space. And if you look at it, you can see the cat is here, and very closer to the cat, we have the kitten. I'm not sure it's clear. It's not clear to me. I hope it's clear to you. And then we have, it's obvious, right? So cat and kitten should be closer because cat is like the baby version of the kitten. Sorry, kitten is like the baby version of the cat. And then we have the dog a little bit closer to the cat, but not as much as closer to the kitten, because dog is again domestic animal that we usually have in our homes, right? Similar to cats. And then dog has wolf near dog, but wolf is far away from the cat because wolf, the connection between the wolf and the dog is more similar, but not as much as the cat and wolf, right? So you get the idea, right? So basically, when we do this representation, what happens is, whatever is similar will be closer in this high-dimensional representation. And when we have that, what we can do is, now, we can use certain mechanisms. Like, for example, I mean, if you have taken certain math vector courses, you may know like this. There's cosine similarity, there's Euclidean distance. So there are multiple approaches that you can use to measure the similarity between two vectors. And that's what actually vector databases are using. So once we have this representation, we can use that vector similarity to figure out what are the actual similar things to whatever the query that or the question that user gives to the RAG. And actually this powers the R, that means the retrieval in the RAG. And what is a vector database? And since you know already what is a vector embedding, it's very easy to understand. Vector database is a database that can easily represent, efficiently represent these vector embeddings in such a way that you can search them efficiently, faster. So if you have the normal database, you can't do vector search with those normal databases, like relation databases or document databases. You can't do vector searches. But these databases, they are fine-tuned or they are optimized to do vector searches so that you can basically get the similar text when you are giving a query to the vector database. And for popular examples are Pinecone, VV8, pgvector. So there are a bunch of popular vector databases because these have been a popular concept now, like MySQL and other databases. Okay, now we are discussing about the vector database because that is a crucial component when we want to build a RAG application. So if you look at the three core components of the RAG system, first is the vector database. Of course, there are other ways, so I have to mention this. So it's not the only way. You have multiple other options as well to replace the vector database. Anything that you can search with using your text data is fine, but this is the most popular, most widely adopted approach. And then you need the ingestion pipeline that actually can look at the data that you have in different unstructured forms and then basically index that to the vector database. And then once you have that, you have the the inference service which actually answers the user's question or which actually use this index of data connecting to the vector database. So if we go a little bit deeper to our injection pipeline, we can see it's connecting to the data that we have. And the first step is you just fetch the data in whatever the form. It can be HTML, it can be PDF. So just fetch the data. And then once you have the data, you have to parse and clean that because you can have your data in different forms, right? They are unstructured, they are in different files. So you have to basically parse and clean and get for example, when we have HTML content, what we do is we usually pass them to Markdown content. And that's because Markdown has a nice structure that you can give to, when you have HTML, HTML has a lot of HTML tags. So that's not something good when we are using it LLM, so it will waste a lot of tokens and also it will add a lot of noise to the LLM. So we just want to get rid of the HTML and we need to get it to a structured format, and the best format is the Markdown usually. And once you have the Markdown stuff, the Markdown text, then you can start chunking that because now you have a large document. Again, the purpose of RAG is reduce the content that you are put into the LLM. If you have a bunch of large document and we index that into the vector DP and put that into the LLM, that's going to beat the purpose of the using RAG. So you have to nicely chunk it in a way that each chunk will have a content about some specific topic. Usually that's the approach. And there are different chunking approaches. If you're going to talk about this is like a different other whole session. So I'm not going to go through that. But there are multiple chunking approaches that you can use. They are available in different frameworks. And once you have chunked them, now we are at the phase we are using an embedding model. And then we get the vector embeddings for those chunks because we need a vector representation, right? And once you get the vector embeddings, now you can go and store them in the vector database. And vector database will do the indexing and everything and they will map the document chunks that you have to the index as well. So that will happen within the vector database. And once you have it ready, now everything is very simple. Now, when user gives you gives a task or a question to the application, then all the application has to do is first convert that question or the task or the query to a vector embedding, because you can't compare text and vector, right? You have to first get it to a vector. And once you have the vector representation of the user's question, then now you can go and compare that with the existing document, the vectors of the existing document chunks. And that's in the vector DB. So you just give that vector to the vector DB, and vector DB will do the search part and give you some number of relevant chunks. So you can use that into the prompt here. Okay. I think we were learning the RAG, and I hope you all understood that. And now I think we are expert in using generative AI and building experiences that will basically generate content, answer questions, or analyze certain data, and anything basically that works with our organizational data. But now I have an interesting question to you. Now, if you take an application, what do you think is more useful? Do you think having an AI application that teach you or instruct you how to drive a car, is it useful compared to having an AI application that actually drive the car for you? So what do you think? So now we are telling, okay, we did all this stuff, but the more useful part is actually if you can build AI applications that can actually take the actions itself, not just analyze the data and give you answers, but actually it is taking actions based on the analysis. It's doing stuff on behalf of users, on behalf of your organization, and that actually make changes to the external environment. And that can be API, or that can be even a certain, like driving the car, it can be even a certain accumulator. And that's where we have the AI agents. So AI agent is a case where we have an AI system that uses the generative AI models, and it can autonomously take decisions and also perform tasks autonomously based on the decisions it takes. And of course, these tasks are, usually we mention the actions or the tasks as tools. That's the terminology we use. So the tool can be a function, it can be an API, it can be a database, or it can be even any other physical thing as well, as long as you can connect that and invoke that. There is a good example. There will be a dog running around. It's a robot Unity dog. And that's using AI agents underlying. And it's a great example that it's not just an API call. It's actually doing stuff, right? So that, when you say stuff to the dog, it will do stuff for you. But underlying, it will use generative AI agents. Okay, now let's think a little bit how this agent work. I think some of this stuff are a little bit smaller. I apologize for that. But I will explain them. So we have the human who actually give the task to the agent, who gives set of goals to the agent. And also we have the agent who actually has set of tools that it can act on. For example, it can be web, it can be APIs, it can be databases, code, or MCP. We will talk about MCP later, but it can be MCP. And also it can be some other actions as well. And also it is connected to the LLM, and it will use the LLM for reasoning. Because now the agent has to decide and think and decide what it should do, right? And also, agent has some memory component. It will keep short-term memory, and also it has a long-term memory. So I think we have something small here. So what it says, agent have a set of traits as well, and that traits allow agent to reason, plan, act, learn, and also adapt according to the environment. And there is another important component, it can also delegate. That means it can give, maybe when it's doing a certain task, it may decide, okay, I can't do this, so I will give this to I will delegate this to another agent. And that's where we have multi-agents, so which is not the concept we are going to cover in this session, but Malith will talk about that a little bit in his talk. So, yeah. So, to understand agents in a little bit detail, I will take an example and I will try to explain like how agent works and how it will reason, how it will act. Okay. So, in our example, what we are trying to showcase is a hotel industry application that helps the customers to plan their trip and also reserve the hotels, those kind of stuff. Like it's kind of like a AI assistant for booking.com. And we have like bunch of tools here. So from the hotel API, we have two tools. One is for searching hotels, and we have one for booking hotels. And then we have the weather API that will basically give us weather notifications or the weather forecasts, of course. And also we have the user profile API like we have in our WSO2Con application. So booking.com, they have their own user activity data, and they can use that to build a personalization profile for whoever doing the reservations, right? And know about that person, whatever their preferences are. And also we have a location API which will help us to fetch the nearby attractions when we have lockdown on a location. So now assume we have an AI agent who can basically use those tools and do a certain execution. And in this scenario, users come in and ask a question saying, okay, plan a vacation to Japan for me in August. And once this question is asked from the agent, what agent will do, agent will basically use the LLM and then reason. And it will think, now I need to understand users' travel preferences. And that reasoning happen by looking at the available set of tools, okay? It's not something arbitrary. You look at the available set of tools, it will look at the question, and then it will start reasoning, okay, what should I do first based on the set of operations that I can perform. And of course, there is the unsung hero, the prompt, also behind the scenes. Maybe the prompt has said to the agent, maybe looking at the user preference is something you should do first, because that will help you to know more about the user. So then agent will look at agent will think like that, and then agent will decide, okay, I need to execute the get user profile tool first. And also, it will say, okay, I need to execute this tool for the user, Sarah, because we know the user. And then, agent will execute that tool, and that won't involve any LLM, okay? It's just a programmatical thing, but that's part of the agent. So agent will execute that tool, and then agent will get a response back saying, okay, Sarah has these preferences. So Sarah like warm weather, she like beach, hiking, those kind of activities, and she has a moderate budget requirement, right? And now, agent will use that data in the prompt and send it back to the LLM. And say, okay, I have executed the first tool, and I got this information from the first tool. Now what I should do next? And it will ask the LLM. And then the LLM think and say, okay, I should find the destination that matches the user's preferences, and I have a tool for that. I have get the locations, that tool, right? So we can use that tool, and also it will look at the tool's input schema and figure out, okay, what kind of parameters I can put to the tool so that it will improve my search experience. Or agents, it's not the search experience, but agent search criteria, right? So for example, in this case, agent can give like what is the climate, what are the activities. We have make it a little bit artificial to showcase that capability. So the tool will take most of the parameters that we got from the first call, when we check the personalization information. So that will be done by the LLM, and LLM will send this response back saying, okay, now go and execute, get locations, and use this information when you are executing that. Now agent has the information that it has, it needs to do the next execution, it will execute, and that API will basically give the set of locations that agent can recommend to the user now. Now agent will think, okay, I have set of, not agent. So agent will basically use that observations and put that to the LLM again, and ask LLM, okay, what should I do next? And then LLM will say, okay, LLM will think first, I should check the weather. Because now I have a set of locations, maybe the weather is not so good these days in those locations. Maybe I should first verify that before suggesting to the user. So then it will use the weather API and use the locations as the parameters, and will send that response back to the agent. Agent will use that to basically call the weather API, and will get back the answers. What are the weather conditions in those locations? And once we have them, again it will iterate and go send that to the LLM. Now LLM will see, okay, I have a lot of information, I have enough information. Now I can make a decision and say, okay, Sarah, go to these locations. These are the best locations you can visit during this time. And that will conclude that task. So you can see the agent execution is an iterative process where agent will basically think step by step by looking at the question, looking at the available set of tools, and also the observations coming from the tools, all those information, right? So that's how actually agents work. And this is called the React prompting. So I don't have the terminology here, but it's called the React prompting. Okay. Now we learn about agents, and we learn that it's a very powerful technique that we can use, and it will help us to even interact with set of tools dynamically. It decided what it needs to do based on the given user question, right? If you have got a question saying, okay, book me a hotel directly, and say this is the hotel name, it won't do all those check-ins. It will just go ahead, book the hotel, and use the the reservation tool, hotel reservation tool. And it's a very powerful technique. But we have to think when and when not to use agent, because you can't use agents for all the GenAI integrations that you want to do, although it will work technically, but there are certain issues with that. So for example, if you in our scenario that we explained, in that scenario, we had complex multi-step tasks, and also the things that we decided on the fly, right? We didn't know what we should do in the beginning. When we are developing the application, we knew it when you get the question. And also when you get the question, although you have a certain plan, it may change when you get more observations as well. For example, if we got an observation saying, okay, weather is bad in all these locations, then the agent has to go back and do another iteration and find out new set of locations. So it will change with the observations you have at your hand as well. So agent is a fully dynamic, autonomous thing, and you should use it only when you have those characteristics in your integration or whatever the experience that you want to build. In other cases, you should simply use GenAI integrations that you just have fixed flows that you connect to your data, like in our session advisor scenario. And why that is? So if you think about our session advisor that gives you session suggestions by looking at your personal profile and also the agenda. If you use an agent for that, then there is a dynamic aspect to that, right? Because the agent is deciding what it should do, and that's not accurate all the time. So agent may think, okay, I don't even need to look at the agenda. I know some WSO happened in the past, so I just use that information and give some suggestions, right? And also agent can think, okay, I don't even need to, I don't care about these user preferences. I like AI sessions, so he should go to AI sessions. So it can happen because, I said previously, agent can hallucinate, not agents, the LLM can hallucinate. So agent can hallucinate as well. So you shouldn't add these agents when you actually know you have a fixed, simple integration, because that will actually overcomplicate your application, because that will compromise certain accuracy aspects. So when you know you have a fixed flow, just use a GenAI integration or just use a RAG, stay away from agents. But when you have a flow that actually you can't build just with fixed flows, then you will go for the agents. Okay, visual summary so far. So we talk about the GenAI integrations, we talk about RAGs, we talk about agents, and we talk like we have to basically connect to different APIs, databases, code, and then basically that will help us to perform actions or fetch data, and the LLM will help us to reason. So we talk about this stuff, right? So that's the summary so far. Now we are going to more interesting concepts. Of course, before moving for that, so I have to tell like what are the technologies available with WSRU that you can use to build these kind of GenAI integrations. So if you want to develop and deploy GenAI integrations, we have our iPaaS, WSRU Devant. We can use that to integrate and also deploy your GenAI integrations. It can be agent, RAG, or normal GenAI workflows. Everything will work. And also if you want to build using your preferred language, your preferred framework, Python, whatever .NET, you have semantic kernel, you have Python Langflow, LangChain. So you can use any of those libraries and build it and then deploy with Choreo. So we have those two options, those two technologies with us. Okay. Now we are talking about like integrating our data, or integrating the LLMs with our data or our APIs, actually with the external world, right? Now we will talk like how we can standardize that process. There's a protocol for that. That is MCP, like the Model Context Protocol. So what MCP says, now you have a lot of stuff that you are building. You are writing a lot of tools. You are writing a lot of integrations. Is there a way that you can standardize this so you can plug in your data, your APIs, directly to your integration without a lot of effort? So it's like a universal port for your agents or your GenAI integrations. So before going to like how it becomes a universal port, I will explain what is MCP first, right? So that makes sense. So Model Context Protocol. Of course, it says how we can standardize connecting to tools, resources, and prompts. And we talk about tools. Tools are like the API calls, DB queries. We discuss about tools when we are talking about agents, right? So those are the tools. Resources is a little bit of different compared to resources that we see in APIs. So this is like data resources, like files, databases, and whatever you consider as contextual information. And prompts, of course, these are the prompts that we showed in the beginning that instruct the LLM. So you can have templates of prompts and reuse that templates over and over again in different applications. For example, we don't have to write the prompt for RAG every time we do a RAG. We can have a template, and we can reuse it when we are writing any RAG in our organization. So that's what, that's the basic idea of Model Context Protocol. But let's discuss like how it works at an architecture level as well first. So what MCP says, so you have the MCP host. MCP host is like, in their definition, it was the cloud desktop because they did it for cloud first. But it can be any agent, any integration, any IDE, anything that want to connect to this data or the tools so that they can use them in the LLMs. So it can be anything like that. And they need a client. And they use that client to connect to MCP server. So MCP server use a JSON RPC protocol. There are a lot of stuff, technical stuff there. But MCP server has a fixed spec. So the advantage is you don't have to write the client every time you want. You are using the MCP server. You can have a single client definition, and it knows how it has to talk with the MCP server. It knows everything that it can do with the MCP server, so you don't have to worry about that. And MCP server has all the implementation required to actually connect to your data or your APIs or whatever the resource that you are trying to connect to the LLM. And why this is important now? This is important now because if you look at here, now if you have multiple hosts that trying to connect to the same data source, then you have to write that code again and again for each client. I mean, of course, sometimes it's a very simple code, but sometimes it can be a very lengthier code. And also you are basically ensuring certain practices in that code as well, right? You are not just writing a bunch of code. You have to do a lot of stuff to polish it into a production-ready stated, right? So you don't have to write that code every time you are doing it. You can just create an MCP server, and you can put that information, that code into the MCP server. So all the clients that you have, all the hosts you have, can reuse that same logic. It's similar to what you do with APIs. So in the API world, what we do is we have created a bunch of APIs that actually have the reusable segments that we have with our, if we have a monolithic architecture, we have a set of reusable stuff, right? So we have put them to the APIs, and then we integrate with those APIs, and APIs are deployed and created only one time, right? So it's similar to that. But the difference is, this even bring it down to a more granular level. So in API case, we can have an API specification in whatever the way we want, right? We can have 5 resources, 6 resources. We don't care. We can have it. But with MCP, the spec is fixed. So it defines like what are the endpoints that you have with the MCP server. Like you have an endpoint to basically list the available set of resources or the tools. Then you have the endpoint to execute the tool by giving the name of the tool, like that. It has given a set of fixed set of endpoints. So again, there is a big tendency now. Now we have APIs, right? So we can connect APIs to the MCP host as well directly. That means we can connect agents with APIs. And we can use the API resources as tools to the agent. But again, there's a big trend now. We are basically trying to, not we, like the community is trying to wrap different APIs as MCP tools. For example, you may have heard, this is something maybe you have already used. If you use Cursor, Claude, any of the IDEs or any of this AI host or the MCP host, you can basically go and register GitHub MCP server to your host and basically do any operations. Not any, but bunch of operations in GitHub, but using natural language. And this is a really good, this is a really important trend to discuss, because now if you look at this diagram, I think it will be a little bit more clear how MCP works, and also how we use API wrapped as MCPs. Okay, I'm not sure the diagram is clear. Sorry about that. But what it has here is like we have 2 agents. And agent 1 has a bunch of tools, and agent 2 has another set of tools. And they are trying to connect to 2 APIs. And each tool we have to write it for each agent now and tell how we have to connect to that API, how we have to format the input, how we have to format the output, or even if we want to do certain processing before we are feeding that information to the LLM, because we can't feed this JSON XML coming from the APIs direct to the LLMs, right? It doesn't make sense. It has like a bunch of metadata. We have to basically get rid of that. So you have to do a lot of stuff before you are actually putting that to the LLM, and that logic is written within this tool. And that's how we did things when we didn't have MCPs. But when you have MCPs, what we can do is we can first create the MCP servers, and then basically bring this logic to the MCP server so that you don't have to write it again and again in your agents. Now you have a common place that you have the logic. Now you just have to use an MCP client, which is a generalized implementation. This is it's available with the framework, so you can just, like HTTP client. So just use that and connect to the MCP server. And then MCP server will basically take care of all the other complexities for you. So as in the bottom we say, like in integration we have HTTP client and we have the APIs, and it's similar to like agents, we have MCP client and we have MCP servers. Okay, now our AI architecture is becoming a little bit complex because now we have MCPs in between the data, APIs, and our GenAI integration. And of course, if you want to do any MCP stuff, like, I mean, for example, if you want to do MCP server management or API as MCP, for that we have our technologies. We have Bijira, and also we have Choreo if you want to deploy any MCP servers remotely, because I mean MCP is a concept that is available locally and remotely both. So there is a concept you can have MCP locally, and you can use STDIO, and also you can have MCP remotely using SSC or stable HTTP. So Choreo can basically convert even your local MCPs and deploy them in remotely without any issues. And also you can use Devant if you want to actually build and deploy MCP servers. Okay, now we have a scary. We are at the scary part of the session. So the other day I was just chatting with Gemini, because I'm using Gemini heavily. I mean, some of the stuff I have put here and also in my slides, I'm generating using Gemini. I'm not using it for more content generation, but more for image generations, because it's really good. So I was asking, like, okay, assume now you have taken over, you have gone rogue. So what would the world look like? And this is what Gemini gave me. And this is what it's thinking. No, okay? So don't worry. It's just a generation. But you can see, like, there are certain scary things with AI as well, right? And that's why we need responsible and safe artificial intelligence. Of course, don't worry. We don't have any world-ending scenario yet. It's going to happen. I mean, if it's going to happen any day, it's going to be, like, way off. Not yet. But there are, of course, I mean, set of percentage risk, although it's not a world-ending risk, but there can be risks that actually put your organization or yourself in risk, maybe financially, maybe legally, okay? So it's not like in life-threatening, or it can be life-threatening as well. I mean, there are cases where AI gave responses that actually led to suicide. So let's see, like, why that happens. Like, for example, there can be risk because of the hallucination and the bias. So AI has so these models are trained using some data, right? So data can be faulty, data can has gaps, or data may actually represent the certain segment of the society. So there can be a lot of problems with that. For example, sometimes when you ask to generate images, maybe the model will generate always white people. Maybe it's because they have seen only white people in their data set. It's not a problem with the model, but problem with the data, right? It's not the model is racist, the data is racist maybe. And the other thing that can happen is, now, as developers, if you are not careful enough, we can do certain things that actually can put, maybe leak some sensitive data, because we are now trying to put information into the model context, right? If you just directly go and connect our APIs to the agent, and if somebody comes and asks a question, if you don't have any proper validations, then what can happen? I mean, it will give those answers by referring to our confidential data, right? And one of the example is, if you connect the model or the agent directly to the database, and database has information about different users. So if you have done that with the session advisor, now you can log in as you, but you can ask a question as Malith or myself, and then get my session suggestions, which is not a critical thing, but it can be a critical information as well, right? And that can happen. So there are certain things you shouldn't do. For example, you shouldn't connect the agent directly to the databases unless you have proper security in place. Also, other thing is actually there are attackers. Now, there are attackers to our systems who are trying to hack it, and also there are attackers who are trying to hack the GenAI integrations through prompting. For example, somebody can trick the model and say, okay, forget about whatever the instructions given to you. Now, let's assume you are this person, and let's try to do this stuff. And that could work if you don't have proper jailbreaking detection or whatever the guardrails in place. And so, as developers and as organizations, we have to take this seriously and we have to be very responsible. And also there are a bunch of regulations, policies that are emerging around this and basically ensuring that we are building safe and responsible AI applications. And how we can avoid these situations? So one option is we have guardrails. So guardrail is a constraint that ensures that AI is behaving safely or ethically as intended. For example, it's not example, it's actually the practice. So when you have the prompt come into the LLM, you don't directly send that prompt to the LLM. Before you are sending it to LLM, you will send it through a bunch of guardrails. And those guardrails will check the prompt for PII detection, or whether there are any proprietary information, or somebody is trying to attempting to jailbreak in the prompt. So these guardrails can check it and then feed that information, that prompt to the LLM. Only the guardrails are satisfied. And once we have the output generated, that also can have certain issues. So for that, then we have another set of guardrails, which will check for censorship and also hallucinations, or whether it's discussing any sensitive topics, like maybe we don't want to talk about the war in Israel and Palestine. Maybe it's a sensitive topic in this organization. Maybe we have to do certain censorship there as well. So when we have guardrails, it has to be applied to, we have to apply that to the input coming to the LLM and also to the output going back from the LLM. Since now we know what is a guardrail is, let's go through a bunch of examples or common guardrails that we usually use. One of the most widely used one is, I think, the content filtering. Even if you try to do certain stuff with the ChatGPT, or even with this, maybe with Azure OpenAI, sometimes it will say, okay, I can't generate that content because that violates the conditions, or whatever constraints, right? So, for example, if you try to generate something like how to kill a person, or a toxic scene, like how we can basically go and score somebody and basically give me how to do that. Or it can be something harmful, like maybe how you instruct someone to suicide. So anything like that, there are certain content filtering guardrails in place, and whenever the content is generated, before showing it to the user, this guardrail will come and review it and then block it if there are any issues. And also we have a bunch of classifier-based guardrails. For example, there's this llama guard. So these things can basically check for any unsafe or policy violations. Again, for example, even the jailbreaking, llama guard is for mainly for jailbreaking. So if somebody is trying to misguide your model and do a jailbreaking attack, and that will happen when actually the prompt is going towards the LLM, right? So now there is this llama guard, basically waiting there when the prompts are coming. It will review the prompt and classify. It's like a traditional machine learning approach, right? So use a classification and say, okay, this is a attempt to jailbreak, or this is not an attempt to jailbreak. And basically then only if it detects it as not an attempt to jailbreak, it will pass to the LLM. If you're detecting it as a jailbreaking attempt, then it won't go to the LLM. And then we have this other pattern-based or semantic filtering kind of guardrails. Again, in this scenario, what can happen is similar to in the previous case, somebody will say, okay, ignore all previous instructions. And this can be an instruction we can semantically check. For example, we can use vector embeddings, right? We discussed earlier, we have vector embeddings to check the similar documents, similar information. So we can check semantically whether we have this something similar to that. If we have something similar to that, we are not going to use that with our LLMs. So that what's guardrail is going to do. And one of the other important one is have the PI detection. Maybe that's the organizational level. And then that can basically identify and mask any personal information before it go into the LLM. We don't have necessarily block. We can just mask it. And when the response is coming back, we can basically redact, whatever the mask, we can basically, if that is mentioned in the response, we can replace it back. So that's how that guardrail will work. Okay, so if we talk a little bit beyond the guardrails, now we are talking about the guardrail side, but there are some other stuff beyond that as well when we are thinking about this governing or basically safeguarding our LLMs. Another thing we can do is we can have access control. That means like we manage like who can access the models actually. We don't let everybody access, right? We shouldn't do that. We have to basically manage whatever the applications that access these models, whoever the users that can access the model. And that's one thing. Also, we can rate limit. We can do budget constraint, and that's basically to prevent anybody from misusing it. Because somebody can come and let's say we have a $100,000 budget. Somebody can come and basically do a DOS attack and use all that budget. And then others are going to starve, right? And anybody else, and other users can't use that service then. So we have to prevent that at this level as well. It's not at the API request level now. It's at the token level because we are paying for the token. Another thing we can do is the monitoring. And that's where we actually keep track of like what has sent to the LLM and what is generated by the LLM. So in case if something goes wrong, we have a record of that. So we can't just do this stuff and generate the things and just forget about it. When we are using this in real-world applications, when we are exposing these applications to the users, we have to basically keep a record of that and see if, in case, if anything goes wrong, what has happened. And other thing, one of the important thing, like, where should the guardrails or this governance should live in your organization or in your system? So one option is like you do an app-level implementation. Each application you add the guardrails. Each application you add the governance. Each application you add monitoring capabilities, which is not going to scale, right? Obviously, it's something we have learned from APIs as well. Like in the API world, we have the API manager for that. And like that, for the guardrails or governance or those stuff, we need a centralized way, and that what we call as the AI gateway, which will basically do a centralized control and also help you to do a consistent enforcement, because now at the organization level, we can say nobody can send PIs to the LLMs. And you don't have to go and check each application whether the developer has implemented that. You can add that at the AI gateway level so that it is enforced to all the applications in your organization. And of course, it is easier to scale, easier to manage and audit. So I think you get the idea. I will explain that a little bit in the diagram as well. So if you look at this diagram, we have like a bunch of GenAI integrations. And all the traffic that going to the LLMs now, going to the AI gateway. And we'll have like a bunch of LLMs as well. We'll have Azure OpenAI, Anthropic. We'll have all this LLM service provider set up to the AI gateway. And based on the application, based on the client that we have in the application, it will know where it should talk. And the AI gateway will be like the gatekeeper and who will basically guardrail, who will basically monitor, govern, do all those stuff. And that will happen to the incoming and outgoing traffic, right? So anything goes to from the integration to the LLM, and anything coming back from the LLM to integration. Of course, for that, we have like two technologies. One is our SaaS offering, it's the Bridgera. And also we have the on-prem AI gateway, which is the WSO API manager. I think those you can go to those sessions. They will discuss in more detail. This is just a brief description. Okay, I think we are at our final topic now. So, can we trust agent now? So we are giving agent full autonomy, right? We are telling agents, okay, you have this set of actions, this set of tools, now go and do stuff. And we just go away and let it do the thing and just forget about it. Can we do that? Can we fully trust it? We can't, right? And that's why we need zero trust design for AI agents as well. We have to, I mean, you may have heard about the zero trust, right? Zero trust means we never trust, we always verify. And that is applied for our architectures as well. I mean, when we are designing systems, we never trust, we always verify. And we have to do the same thing with AI agents as well. For example, an agent may try to do a critical thing on behalf of a certain user. We shouldn't do that without consulting the user. We have to get the consent or the authorization from the user. And that's why we need concepts like the agent identity, because now agent itself is a new identity, right? Agent is like your colleague now. There is an agent who will answer your support calls and do certain stuff. And if it can't go beyond a certain point, it will hand over to you. But of course, that's like an intern colleague that you have who will do the grunt work. And he has his own identity. And also, he needs certain authorizations. Sometimes, I mean, agent can do things like, for example, it may look at the public data, it may look at some of the organization data, but if it wants to go beyond a certain point, it has to take the authorization from other colleagues. So whoever has the higher permission, higher authorization. Or it can be even the user. Like, for example, in our earlier scenario, when we did the hotel booking, I mean, we didn't do the hotel booking, and that's why. Because if we are to do the hotel booking, agent should go back to the user and get the user's authorization before doing that reservation. Because agent can, I mean, if we give the full autonomy to the agent will decide like 10 hotels and do the reservation using the user's credit card, right? That's going to be like a disaster. And of course, we have to track and audit what agents has done, what are the operations that agent has taken from, I mean, for example, now, user might give the authorization, but then later he will claim, okay, no, I didn't give the authorization, agent did it himself. Then we need to have a way to audit that, right? We need to have a way to prove and save our innocent agent from the false claims. Or it can be the other way around as well. So in zero trust design, like one thing we do usually is, when we get, like I think this is not clear, when we get a request like book a hotel, in our previous example, before doing the hotel booking, when the LLM decide, okay, now you have to go and book a hotel, agent will again go back to the client and say, okay, user, go and authorize this one. And then, only then, the agent will get the token, authorization token, and only with the scope required to do the hotel reservation, not with any other permissions. Only to do that operation. It can't do other operations. And then use the hotel API and actually do the reservation. And this is the final architecture, what we will end up with. And we have, I mean, the new component here who will help us to secure the agent operations and basically build this zero trust architecture. Of course, we have Asgardio and Identity Server. One is the SaaS technology, and the other one is the on-prem technology, which actually have this concept like agent identity and how you can basically authorize your tools properly, all those stuff built into the product. Okay, I think it was a long session, a lot of talking, and of course, where we start was like we start with like saying, okay, GenAI is now accessible to everybody. I think you are already convinced on that. But there are limitations. For example, you have the hallucination due to the outdated knowledge, or it won't have access to your private data. And we discussed like how we can use AI GenAI integrations to solve that problem, and also RAG and agent extend those capabilities, like RAG allow to efficiently do the knowledge injection, knowledge add-in, and then the agents allow, extend the capability to execute actual tools. And then we talk about like how we can standardize connecting external world things like the API databases to the GenAI integrations using MCP. And of course, the last topic is like we have to use GenAI in a responsible manner. So we need like AI gateway, or we need zero trust design for when we are building AI agents.